Now see the part 5 of solid state. Next question is correct statement regarding defects in crystalline solid edge. So it is talking about the crystalline solid defects, right? So I will write the points. In Frankel defect, smaller ions means cation are delocated from their usual site to the interstitial site. In Frankel defect, a smaller ion, right? That is cation are dislocated, right, from their usual sites to interstitial sites. Interstitial site, right? So this is the main point for the Frankel defects. Now see, Frankel defect is shown by the compound having large difference in the size of cation and anion. Next is Frankel defect is shown by compound having large difference. Having large difference in the size of cation and anion. Size of cation and anions. Right. Hence, alkali metal halide do not show Frankel defects. It means alkali halides means group 1, that is called alkali metal, right? So it is connected with X. X means halides, right? So do not show Frankel defects. Does not show Frankel defect, right? So this is the main point about Frankel defect. Now see the Scotty defect. So it will be in a Scotty defect decreases the density of crystal. So Scotty defects decreases the density of crystalline, while Frankel effects has no effect on the density. Next point is Frankel defect has no effect, right, on density. Now see the question number 4. With which one of the following elements silicon should be doped so as to give p type of semiconductor, right? So it is talking about silicon. Silicon means Si. It is doped with the p type semiconductor. P type semiconductor. P type means it comes under the group 13. P type. P type means lack of electron. Lack of electron. Understood? So it comes as boron, aluminum, gallium, indium, thallium. It is also called as Baigan, Alu, Gajar in Thaila. So general electronic configuration is NS2, NP1. So this will be the general electronic configuration of group 13. Right. So as we know, silicon atomic number is 14. So it is 2,8, 4. Right. So 4 is the valency of silicon when it is doped with 3 electron. That is group 13. Then it forms p-type semiconductor. Right. So if silicon is doped with any of the group 13, that is Baigan, Alu, Gajar in Thaila, of the periodic table, it forms the p-type semiconductor. Right. So option will be the boron given. So boron will be the correct answer. Asked in 2007. Now look at the question number 8. If NaCl is doped with 10 raised to minus 4 mole percent, so NaCl is doped with 10 raised to minus 4 mole percentage of strontium chloride, SrCl2, concentration of cation varies will be. So it is talking about concentration. So it is of cation, right? So for Na, that is Avogadro number, it is equal to 6.02 10 raised to 23 per mole, right? So it is asked in 2007. As cesium ion introduce one cation valency, therefore concentration of cation will be percentage of the mole. So it is given 10 raised to minus 4. Divide by 100. So concentration of cation is equal to 10 raised to minus 4 mole percentage. So it will be 10 raised to minus 4 divided by 100 into 6.023 10 raised to 23. Hello. So it's come out to be 6.023 10 raised to 17. So this will be the concentration of cation. Very simple question. Now see the next sum, sixth one. The appearance of color in solid alkali metal halides is generally due to. So it is talking about the color of the compounds like alkali metal halides, that is MX, metal, or X means halides, right? So F center are the sides. So it is F central are the side and anions are missing. So anions are missing from here, right? And instead electrons are present. Electrons are present, so they are responsible for the color. So due to the electron, it is responsible for producing color of the compound. Now look at the question number 7. A Scotty defect in crystal is observed. It is talking about a Scotty defects. Right. So in a Scotty defects, equal number of cation and anion missing from the lattice side of the crystal. So what happened to the Scotty defects? Equal number of cations and anions are missing from the crystal lattice. From lattice, right? So crystal remains neutral. So crystal remains neutral. Yes. Such defect is more common in highly ionic compound. So it is mostly occurred into the ionic compound. So it will be the like NaCl, sodium chloride, mostly found in sodium chloride. Now look at the question number 8. If we mix a pentavalent impurity in crystal lattice of germanium, next is pentavalent impurity. Right, in crystal lattice of germanium. Right. So which type of semiconductors it is formed. So when a pure atom with 5 valency electrons, so pentavalent means 5 electrons, 5 valence electron, like arsenic. So for 5 valency it comes under the group of 15, right? So electronic distribution will be 2, 8, 5. So it comes like nitrogen, phosphorus, arsenic, antimony, bismuth. So Nepal, Pakistan, Australia, sub Vikhari. So N for nitrogen. How will you remember it? It is Nepal, Pakistan, Australia, sub Vikhari. So N for nitrogen, E for phosphorus. So when any group 14 combined with group 15, it forms the N-type semiconductor. Right. So it is introduced with the germanium. It replaces one of the germanium atom. 4 of the 5 valence electron of the pure atom from covalent bond, which is carbon or silicon. So this is come under the group of 14. Right? So it start from carbon, silicon, germanium, tin, lead, Pb. So it is talking about germanium. So germanium having 4 electrons in the last, combining with 5. So total 9 electrons are there. N-type semiconductor it is forming, right? So majority carrier here is electron. Majority electron carrier is electron. Now look at the question number 9. So ionic solid which a Scotty defect contained in the structure. So when atom is missing from the normal lattice side is created such as equal to the cation and anion. So cation is equal to anion. Then this defect is called Scotty defects. Scotty defects. Right, when equal number of cation is equal to anion missing. It's called a Scotty defect. Now look at the question number 10. On doping germanium with little iodine, indium and gallium, which type of that one we get? When germanium is doped with indium and gallium. So group 15 is group 15. Nepal, Pakistan, Australia, right. And group 14, we know. Group 13 is Bagan, Aloo, Gajar in Thala. So it comes indium gallium. So it comes under the 13 now. So it will form the p-type semiconductor. Right. So it's done, solid state.